I'm Tim Reeser, president of Lightning Hybrids, here today to talk about a system we've been developing for the last 4 years. It is a hydraulic hybrid system made for buses, primarily cutaway buses, but anything all the way from a small van to a very large cutaway bus. What you see today is on a General Motors platform. We also build the system for a Ford platform. It's a system that can be installed after the fact as a retrofit, or also installed as on a brand new vehicle as an upfit. What we start with on this system is a brake change, a small different sensor on the brake, and we tap into the throttle position sensor at the accelerator pedal. When you hit the brake, you're coming out of the lot and you hit the brake for the first time, what we're doing is collecting that braking energy. The industry often refers to it as brake regeneration. So we're taking the braking energy when you hit that brake pedal, and as you hit that, we're turning on one or two of these pumps. If you're going very fast, we might turn on two. If you're going slow, it might be one, or it might go from two and then drop to one. What's happening when we turn on those pumps is it puts a drag on this drive shaft. When you drag on this drive shaft, it naturally slows the vehicle down and provides braking. But the other thing it does is, as you put the drive on the drive shaft, the drag on the drive shaft, essentially this drive shaft is turning these pumps. When you turn the pumps, you take fluid from a low pressure tank here, it circulates into the high pressure tank and builds up pressure. So what you see on the accumulator, this is what I was referring to as the high pressure tank. It is a hydraulic accumulator. What you see from the hydraulic accumulator is a bladder that's filled with nitrogen on the inside and a carbon fiber aluminum tank on the outside. When that pump pumps fluid in, this bladder comes forward, pushes down like a spring until you get to 6,000 pounds per square inch inside this accumulator. That's where your energy storage is. Think of this like your battery, only far more efficient and much faster charge than a battery. So now that we've finished our braking cycle, our accumulator is full of energy. We've got 6,000 pounds per square inch. Now it's time to accelerate the vehicle. The driver pushes on this accelerator pedal. When they do that, we look at the throttle position, how much torque the driver's looking for, and we then look at whether or not we have pressure in our tank. If we have pressure in our tank, we then tell the motors to go. Our pump and motors here act as a motor now. They turn the drive shaft. So in the braking event, the drive shaft turns the pump. And now the acceleration event, the motors turn the drive shaft. So as the motors turn the drive shaft, you go forward. As you go faster and faster, the energy comes out of the high pressure tank, circulates back into the low pressure tank, and then after you get up to speed, we blend back in the engine. Then when you brake, we do that whole cycle again. We go back through the drive shaft turning the motors, the pressure coming from the low pressure into the high pressure. Next time you accelerate, the same thing. Pressure coming out of the high pressure, back through the motors, back through here and accelerating you forward.